Okay, so this first one, um, you have, I'm going to give you a big hint. These two are on the same side of the transversal, and they're in the interior of the parallels. Same side and interior. So what do you think it's called? Same side interior. Haha, Mrs. Sabe, you're funny. Okay, so here's the box for same side interior in our foldable. And it says that they add up to 180. So I'm going to write same side interior. And then B equals 180 minus 86, which is 94, I believe. Okay, and the last one here, number 25, this is my favorite. These guys are like on opposite sides of the where the intersect. Yeah, vertical. Yeah, that is my fave. Everyone can find vertical angles. They might be the easiest to find. Okay, and vertical angles are in this box. And it says their measures are equal. So B equals 87 degrees. We only have one more day of warm-ups. How exciting. Okay, next, can you find the notes that I did not finish on Tuesday? Domain and range is really challenging topic. This is in your notebook, by the way. This is the thing that we cut out and pasted in. And we're going to do 14 domain and range problems today. You heard me. 14. So what I need you to do is settle in for the domain and range problems. I'm going to use an orange pen and my blue pen for all of the pictures. Okay, so first for the notes. Okay, so first for the notes, we go to C. And also, I want you guys to know that I know that these problems are hard. And you might not get it the first day, and you might not get it the second day. And I have to be honest with you, the Talbot children still ask me how to do domain and range, and they're in like calculus. So it's just one of those things that's hard. But if you do get it, great. So C. So I just want to remind you that domain is X and range is Y. And I'm going to write with my orange pen on the X-axis itself. So I'm going to start here at the very left of the graph. And my graph goes through here, through here, through here, through here, and then it stops right there. That's its very rightmost point. So left to right. The left is -3. The right is 5. And domain is X, so you put an X in the middle and then less than or equal to, less than or equal to. Aren't you glad that this wasn't on your quiz today? We're not ready yet. It was on the Math 3 quiz yesterday, though. Oh, I mean Tuesday. And they were still like taking a while. Okay, C. The bottom of the graph is down here, and then the top is here. So very bottom to very top. The very bottom is -4. The very top is 1. Why? Because it's range less than or equal to, less than or equal to. Okay, now the mapping diagram, this is my favorite. Do you see that it labeled it for you already? So the domain is just a list of these. X equals -5, -4, 0, 4, and 7. The range is just y equals -1, 2, 3, and 6. You literally just list them. Okay, so now let's go back to these two. Is this one a function? Yes. And it's a little harder to see maybe on this one. Is this one a function? Yes. And the reason is because all of the x's have their own arrow only going to one place. It doesn't matter that both 4 and 7 are going to 2. That's okay. It just means like when you were talking about the soda machine, it just means that there's 2 buttons with blast. That's okay. All right, now if you guys could scoot your notebook to the side. You've got your packet. We're gonna do the giant menagerie of more of these. Just wait till you see the page. Just mentally take it in. Okay. What I think we should do first, let's just go, before we mark up any of the pictures, because we're going to mark up the pictures with the domain and range, let's just look through all of them and say whether or not they're a function. I want you to, in your groups, take 2 to 3 minutes, go through, just do the function part. All you have to do is say yes or no. Just go through, write yes or no for just the function part. Ignore the domain and range for now. You can talk to each other about it. When you think you're done, maybe you guys could share your answers in your team real quick and see which ones you have the same and which ones are different. All right, you guys, let's just check what I got. I got for the first 6, no, yes, 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 yes. No, yes, 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 yes. Do you want to talk about any of those before we move on? Why they are what they are? And I'm actually sort of referring to this one here. Did anyone think that these arrows were going to start to go vertical at some point? And you might have thought that to yourself, but they do not. They will go forever left and right. just really slowly. Okay, any questions about the first 6 at all? How'd we do? Okay. All right, 7 through 12. I got no, yes, no, yes, yes, no. Raise your hand if you got them all right. Yes. Okay. Now, let's go back. That was the easy part. Let's go back to the orange pen. I'm going to do the orange pen and the blue pen again. And I'm going to draw only on the axes. So the orange pen will never be in the graph itself. It's always going to be on the axes. And this first one is already challenging. There are only 2 spots where this graph exists on the X. This spot and this spot. That's it. And when you only have dots, you make a list like this. Domain equals -3 and 2. Okay, but the range has arrows. So I'm going to draw on the y-axis. I'm going to start here because there's an up arrow going forever. And this piece of the graph goes down to here. And then this piece of the graph picks up right where that one left off. So that covers everything. All real numbers. Okay, and I want to clarify, this is a R with 2 stems. That is not an I. This is R with 2 stems. It's just like a fancy cursive R. Okay, next one. Number 2. Starts here. Okay, but I want you guys to notice this is really important. This side is open. I want you to put a glaringly open circle on there. Remember that your teacher is just aging every minute. Her eyes are getting worse all the time. So you got to make it like a big open circle so she can see. And then the graph goes here, here, all the way to here, and it's closed on this side because that circle's filled in. Okay, so this is a new thing for today, I think. This side starts at -5, which should not be in orange. And it ends at +5. So I have -5 to 5. And then domain is X. And you know how normally I put less than or equal to and less than or equal to? This side is just less than because it's open, closed. You see the difference between open and closed? Okay, now the range. The bottom of the graph is here. The top of the graph is here. Put in my circle. Do you guys see that it's open here and closed here and closed here? Do you see that it's both open and closed? Okay, when it's both, that means it's closed somewhere, so it's closed. If it closes at any point, it's closed. Okay, so that goes from -2 to 2. Range is Y, and they're closed on both sides. Okay, number 3. This arrow is going to go forever to the left. So I'm going to put my arrow to the left. The graph goes through here, through here, through here, and this arrow goes forever to the right. So that's all real numbers. And this arrow goes up forever, and the graph goes through here, through here, through here, through here. And this arrow shows it going down forever. So the range is also all real numbers. Okay, move down to the next line. Okay, domain. Forever to the left, everything here, everything here, everything here. Okay, so that's all real numbers for the domain. And then the range actually is only one spot on the Y. This graph only touches one place on the Y right there. So we put equals Y equals. Okay, do you guys remember what we do when it's dots? Anybody remember what we do when it's dots? Yes, list them. Okay, so we have a dot here, 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 and we have a dot here. So x equals -3, -2, 1, 2, and 5. And then we have a dot here. We have a dot here. We have 2 dots here, but we're only going to list it once. We have a dot here. I just want to stress to you that whenever you have dots or a table or a mapping, they all look like this. All the domain and range looks like that. So dots or a table or a mapping always looks like that. So much easier. Okay, number 6. This one's hard. Okay, so this goes forever this way. The graph goes through here, goes through here, goes through here, and stops right there. Okay, this shape is a ray on the x-axis. And when you have a ray, you write an inequality statement with just one direction. So you have x is less than or equal to 4. Notice that my arrow points in the same direction as my arrow here. You can sort of use that to help you. Okay. Now, this is going to go forever up. It doesn't look like it, but I promise you it is. Goes here, 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 and the bottommost point is right there. Again, this is a ray. So when it's a ray, it looks like an inequality statement like that. Y is greater than or equal to 0. Greater than or equal to because the arrow is going up. Okay. Now I need you to pause and answer my favorite math joke because I can tell that you need a break. What did the 0 say to the 8? What did the 0? This is my favorite math joke. If anybody needs to catch up while I'm taking this break. What did the 0 say to the 8? None of you have heard my favorite. This is great.
What does 0 say to 8?
Yeah. What does 0 say to the 8? It's going to be an unsatisfying response. Prepare yourself for an anticlimactic answer. It is nice belt.
Oh, wait.
Okay, think about the shape of a
Oh,
zero
because it's like,
and the shape of an 8.
and it's like this. So
It's like
a
this.
bell.
Nice belt.
I get it.
My favorite. I do like the why is the 6 afraid of 7 joke too, but it's not as good as the nice belt. Okay. You should definitely tell that joke later today to someone else. Yeah, you should definitely pass that one on. It's a gem. Okay. Now back to this just fun madness. Okay. What do you guys think about number 7? I think number 7 is doable for somebody like you at this point. What do you guys, anybody want to offer anything for number 7? This one is not super hard. Where, okay, let me ask you this. Where is the very left? -2. And is it actually touching there? Yes. Where's the right? 2. Okay. So when it looks like Baymax, which is the best way I have to describe that, -2 to 2, X in the middle, closed, closed. Okay. 1 to 5. Beautiful. One to 5. Y, closed, closed. Okay, number 8. This looks like it's going to go vertical. I promise you it's not. It's going to go forever to the left. And this looks like it's going to go vertical, but it's not. It's going to go forever to the right. I have arrows going forever up, and then the graph comes down, and the bottom is right here. That is a ray. Y is greater than or equal to 0 because the arrow is going up. Okay, I really like number 9. Number 9 might be my favorite. I hate number 11, by the way. It's just unnecessarily difficult. Number 9, I like. Okay, what is the very leftmost spot on number 9? -4. Great. And it actually touches there. So what is the rightmost spot? 3, but it's open. I'm gonna make it look like really obnoxiously big so I can see it. Okay, so we're gonna go -4 to 3, X, closed, open. Closed, open. Okay, now the range, is the bottom open or closed? Open, beautiful. Is the top open or closed? Open. Open, open. Oh my gosh, we're in the home stretch, everybody. And then we have one more thing to do after this, but most of it should be review from middle school. Much easier than this, I think. Okay. Left forever. Right forever. up forever goes down to here. Y is greater than or equal to -3. Okay, let's come back to number 11 because it's just so wrong. I don't think my math kids could do number 11 without me. But number 12, give number 12 a go in your groups. You can do it. Try it yourself. Number 12 is not bad. I promise you. Give it a try. Okay, how do we do? X is -3 to 3. Y is -2 to 4. Is it happening? Are we getting it? This is the difficulty level of the type of problem I'm hoping for. This guy, please do not feel bad if this one is terrible. Okay, last one. Let's just get it over with. Okay, so first, you can tell that this is the very left and it's open. So I'm going to put an open circle there. Okay, and then I travel along, but there's also an open spot here. And then I travel along, and there's also an open spot here. And then I travel along and forever that way because of the arrow. Holy spicoli. Okay, so we say it's a race still. So we say X is greater than -4 because my open circle is at -4. That covers everything. And then you put comma. X does not equal -2 and 2 because that's where the open circles are. Isn't that horrible? Okay, now the range isn't so bad. So if you guys actually extend this arrow down, it will really help your brain. It goes forever down and then goes up here to here. Okay, and you might be wrestling with your mind, should I put an open circle right here? And the answer is no, because it's closed on this spot. And then you might say to yourself, should I put an open circle here? And the answer is no, because it's closed at this spot. So this is just y is less than or equal to 1, believe it or not. Hallelujah, we're done with that. Okay, you need to take a mandatory 3-minute break. And you must talk about, did we do the phobias one already? Must talk about your biggest phobias in your group. Required. What are you most scared of? Is it domain and range? Just kidding. Okay, I haven't sent anybody for that yet.
Oh, okay.
You're completely up to date. So this is going on forever. So that means it's going down forever. And then the graph is going here, and then stops right there. So y is less than or equal to 1. It's so hard.
No,
It should go least to greatest for both the domains. Okay, so last thing we're gonna do is a middle school review of exponents. Wait, worse than domain and range? What's worse, exponents or domain and range? Really? That is unexpected information that you just gave me. This is all going to be review, I hope, unless you maybe didn't go to Benicia Middle School. And then maybe you haven't seen it. It's excruciatingly annoying today because I'm going to make you write out the exponents because I'm a jerk. However, we will be learning the shortcuts. Also, did you guys learn scientific notation? Where you like move the zero over, like move the like decimal over and then write it like times 10 to the. And we're doing that today too. And you definitely need a calculator for that. So you should have one from the quiz. So. Okay. Be prepared for annoyance. Here we go. I know you're gonna hate it. Just not the problems themselves, but just the definition. We need to make sure we establish a definition of exponents today, just in case people didn't get it before. So y to the 7th times y squared. is y times y times y times y times y times y times y. There's y to the 7th. Do you see him? Y to the 7th. And then times y times y. Y to the 7th times y squared is y to the 9th. And I'm really trying to make sure you don't put y to the 14th. And I'm really trying to make sure you don't put like 2y to the 14th. Really trying to like head all of that stuff off at the pass. Okay, now B. B is very important because I want you to notice the 3 is only on this part. So it's 5 times 2m times 2m times 2m. Only the 2m part repeats 3 times. Okay, what's 5 times 2? 10 times 2, 20 times 2, 40. And then how many m's? 3. Okay, x cubed squared. This is the same thing as x cubed times itself. So x cubed occurring twice, which is x times x times x. There's the first x cubed times x times x times x. That's the second x cubed, which is x to the 6th. Okay, now how could I get x to the 6th from the original problem without writing all of that stuff? Yeah. Yeah, multiply 3 times 2, 6. So we're learning shortcuts. At some point, I just want to make sure we establish the definitions today. Okay, so this guy. 4 times x times x times x times x times x. So there's 4x to the 5th y squared times x times y. That's xy right there. Okay, so that's 4. How many x's do I have? 6. And how many y's do I have? 3. And how could I get 4x to the 6y to the 3rd without doing this whole giant dealio here? Yeah, okay. So you can put a 1 right there, and you can put a 1 right there, and then add the exponents together. Do you guys know what I mean by putting the 1? Okay. Okay, now 65. 65, we're going to look for ones, giant ones. If you went to Benicia Middle School, you know what I mean by a giant 1. A giant 1 is something that's the same on the top and the bottom, and we can cancel it and make it 1. So that is a giant 1 because when x divided by x is 1. So this is 1 times x, which is x squared. X times x times x times x times x times y over x times x. Okay, do you guys see any ones? Yes, there's 2 of them. 1 here and 1 here. So I have 1 times x times x times x times y which is x to the third y. How do I want to do this? So there's 3Ks. Five more Ks. Over 2Ks. Every time I do this problem every year, I think about South Park and the counselor. Anybody know the counselor from South Park? Nobody? Nobody knows the counselor? What does he say? Okay, 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 okay. Isn't that not him? Or is it the teacher with the puppet? I'm the only one who's a bad person that watches that show. It's not a good show. It's not a good show. But whoever it is funny. And he says, okay, okay, okay. And every time I write this problem down, I'm like, okay, okay, okay. Okay, how many ones are there? Two. And how many MKs am I left with? 1, 2, 3, 4, 5, 6. All right, last one of this. How many ones? Two. Perfect. Okay, and I have 16z over 8. What is 16 divided by 8? 2z. Okay, so I'm gonna put up number 66. I want you guys to try this one on your own. So it's basically a combination of these things from 64 and 65. I want you to give it a go on your own. I mean, in your group is fine. Put up the answers in a couple of minutes. Do you have to draw them all out? Not if you get what's going on. You do not have to write all the letters out if you don't need to. You can definitely speak to each other. That's fine. So you should have 3 and then 4 and then one more for a total of 8 H's. No, there's no fraction there. Hold that thought till B and C because you do have fractions in those. I think I know what you're thinking for C. Not yet, not yet. Okay, so spoilering slightly, there's my answer for A, maybe. 3 H's and 4 H's and another H makes 8 H's. Okay, easy one. You did not need to write all the H's if you didn't need it. Okay. Here's B, B's harder. I got 13p squared q cubed. And that one is hard to organize. You're crossing out. Have to be careful. Okay. Okay, C is the hardest one for sure. This is the answer for C. I did not have anybody have it right that I looked at. Okay, so the moral of the story is if you cross out everything on the top, those are ones. Those are giant ones, so it needs to have a 1 there. If you put W to the -3, you're ahead of me. But it would not be a correct final answer. So all the final answers need to have positive exponents. And then the last one's x to the 8, which isn't too bad. Hardest one was C for sure. Okay, now we're gonna do some scientific notation stuff quickly because I see that you're fried and I understand. This is calculator, basically. Hopefully. Okay, first problem. When you have numbers in scientific notation, this is a division problem. First, can you recognize it as a division problem? Because it's a fraction. Okay, so what you do is you take the numbers in the front and you divide them. Take the numbers in the front and divide them. And then put times 10 and then subtract the exponents. Because when we divide, just like this one, we did 5 minus 2 is 3. We subtract the exponents. Okay, so what is 12 divided by 4? 3 times 10 to the 6. Do you guys see where all the numbers went? Okay, now this guy here is multiplication in disguise. When something is squared, it's times itself. Okay, so what you do is you take the 8s in the front and multiply them. So you take whatever numbers in the front and multiply. And then add the exponents. Okay, this is the last problem we're doing today. This one has a little bit of a spicy level to it though. Okay, that's not the final answer. Very last thing we're doing today. Anybody remember the rules of scientific notation? The number in front has to be something specific. Yes. In between 1 and 10. So it has to be 1 digit in front of a decimal. Okay, this one requires balancing and it makes it harder. So what I want you guys to do is put your decimal point right here. Do you guys see that there's 2 numbers in front of the decimal? That's not proper scientific notation. You need only 1 number in front of the decimal. Okay, so we're going to make this, we're going to go down a power of 10. We're going to take 64 and make it 6.4. And if we go down a power of 10, we need to balance it by taking this up a power of 10. I don't know how much time you guys spent on that. We're gonna do a lot of practice of that. This is not the only one, I promise. And we are done. However, do you know what the homework is? $68 to $70 and $72 in the CPM. Also, just to make you happy, tomorrow we're doing a thing where I'm not talking at all. So that's good.